1 equals 1. Um, it looks very similar to sine x sine squared plus cos squared equals 1, but that's, I think, it doesn't relate so much.
So the difference is if you were to divide this by cos x, so if you were to divide everything by cos x, so for the first bit you'd get 3 tan x, so that's fine. Second part you would get 4 times 1, which is 4, because cos x divided by cos x is 1. But then the problem is you'd get 1 over cos x, and so you haven't actually made it any simpler. You couldn't solve this because it's a mixture of sine and cos, and now you can't answer this because it's a mixture of tan and cos. And so for this one you would have to apply the double angle formulae. Do you know already how to do that?
On to this one?
Yeah, it's kind of like double angle formulae in reverse.
I'm looking through the list. Would I have to square some stuff?
Is there a double angle formula that has sine x plus cos x? Like something sine x plus something cos x, something like that. Like sine A, sine x, cos A, cos x, might look something like that.
Oh, those. I've been looking at the wrong ones. Is it double angle or compound angle?
So they're the same thing.
Okay.
Or
so
compound angle. Compound angle, I should say.
Yeah. So this one is, we'll work with tan, right?
Well, is there any compound angle formula that has something sine x plus something cos x?
Yeah. There's the sine theta plus whatever the cos theta minus something.
So let's just use this one. So we want sine x plus cos x. So this very first one has a plus in the middle, and it has sine first and cos second. And so so the only way this is well, another way to write this would be sine x times 3 plus cos x times 4. So it would look like that. And so what do you know about the 3?
Not much. I'm not too sure.
So 3 must be equal to cos b.
Okay. Oh, I see. Yeah.
So what would you know about the second half?
So then the 4 would be equal to sine b.
Yes, 4 would be the...
Oh, that answers something that I was a bit confused about in class, actually.
Yeah, go on.
Well, no, it was just that we were going through one of those. Maybe we can actually work through it on the question. It was, write sine x plus, or 3 sine x plus 4 cos x in the form r sine x plus a. So essentially the same question. Yeah, it just wasn't very well explained.
And so this is like where it comes from. Okay, and how do we go about writing it as r sine a plus b or anything?
So we need to find the coefficient kind of thing.
Right.
Of sine. So here I've done trigonometry.
Yeah.
So I've used Pythagoras' theorem.
Yep.
But I'm not entirely sure why.
So I believe we could do it using did I not show it either? I believe we could do it by simultaneous equations. Let's see. What if we were to square the top, square the bottom? So it's like simultaneous equations. if we were to square these, 9 equals cos squared b, and then that one is 16 equals sine squared b. What is sine squared x plus cos squared x?
1.
So if we were to add these, that is 1. I don't know. Maybe I shouldn't make it 1. I don't. So that's going to be 25, and then we square root it. But why? Why is it Pythagoras? I think I proved it in a different one. It's not.
Here, the question we did was rewrite 3 sine x plus 4 cos x in the form r sine x plus a.
Yeah. So r is always just the Pythagoras of the two. Perhaps it's not easy to prove. I get the feeling that it is. R sine. It's probably easier to prove in reverse. Yeah, it's probably easier to prove in reverse. Okay, so we'll just do Pythagoras for now. So if you did Pythagoras, what would you get?
So you would do the square root of 3 squared plus 4 squared, which happens to be 9. 5 even.
Yeah. And so it's going to be 5 sine x plus alpha. And how do we get alpha?
So from this point, what I did was r sine alpha over r cos alpha equals tan alpha. But also above, I did r squared sine squared alpha plus r squared cos squared alpha equals r squared.
Right.
And it's just looking like a whole load of confusion.
I think that's probably where the Pythagoras comes from. So this is so far 5 sine x plus alpha. We can do simultaneous equations. Do 2 divided by 1. What do you get?
So you get sine over cos, which is tan.
Yeah.
So that's tan 4 over 3.
And so that's equal to 4 over 3. And so tan b is equal to, or let's say tan alpha is equal to 4 over 3. And so alpha equals?
Inverse or arctan 4 over 3.
Yeah.
Which is a number. Which is 53.13. And is that in degrees?
Yeah.
Okay.
Yes. So you can show it using graphs where it's a transformation. So it's a stretch by the Pythagoras, and it's a translation by the alpha because it's moved 51.1 degrees to the left because it's x plus alpha. But I would say big picture is you can't solve this using the old method. You have to solve it by first putting it into the form of a compound angle, and then you can solve it. And the way you do that is to find the r, you do Pythagoras, and to find the alpha, you do arctan of the second over the first. Is that right?
Yeah.
Yes. But maybe just write it out just to be sure, because they kind of swap around, like a minus b, might not be obvious which one goes where. And it sounded like in your one there'd be a way that you would see the Pythagoras.
Yeah.
So we could try lots of these.
Yeah, please.
Yeah, so here's just lots of questions. So let me just check something. Yeah, I've got the answers. Okay, so try any of these, and I'll just paste in the formulae there.
Okay.
Just squash these up.
Can you hear me okay?
Mm-hmm.
Okay. In the form r sine theta plus alpha. Okay. So I'm trying to think again of how you started off, because that's the thing I always forget.
So
you divide was?
no, that won't work anymore. So R is the Pythagoras. So I'm just going to call them A and B. So let's say A squared plus B squared and square root it. That's R. And then the alpha was arctan of B over A. So
does that happen all the time, no matter what?
I believe so. I could be wrong.
Okay.
Let's find out.
Okay. And why does it happen that R is always Pythagoras?
Oh, you keep asking me that. I'd have to. I proved it before. I remember it wasn't difficult. I think you said it already. There was some way, like you said, R squared, something like that.
Yeah.
I think it's somewhere. Yeah. It's somewhere in there. And you saw how if I did my one and I was squaring them, and if you add them, you get like the sum of the two squares, and then to solve it you'd square root. I think there's something there, but I'm not sure if it's difficult to prove. But I remember it wasn't. I think it wasn't difficult, but I don't know off the top of my head, to be honest.
Okay.
I could look it up, but you don't have to prove where it comes from.
Okay. So to continue with this, it would be the square root of 5 squared plus 2 squared, which is 25 plus 4. So the root of 29, which is 5.39.
No. Just leave it as root 29. It's fine.
Okay. I'll just write that out. Choose the root 29. And alpha is arctan of A over B, which is 2 over 5.
Mm-hmm.
And that gets you 21.8.
And so what is this in the form of R sine theta plus alpha?
So that would be root 29 sine, then theta plus 21.8.
And where is this? I got that wrong. These aren't the answers. These aren't the answers at all. Oh, okay. Let's do 4A. You got that one right. Let's do 4A.
Okay. 4A. So 2 sine theta minus 3 because theta in the form R sine theta minus alpha. Okay, so you use the same rules as before. So you get the root of 2 squared minus plus 3 squared.
Let's try it.
So is it plus minus 3 squared?
Yeah, it'll be the same thing because 3 squared is the same as minus 3 squared.
Yeah. So that's 4 plus 9, the square root of that, which is root 13.
Yeah, and I wouldn't even do any of it in your head, in case you make a mistake. Just put like 2 squared plus 3 squared or however you want to do it.
Okay.
Okay, go on.
And then the next is the arctan of minus 3 over 2.
Mm-hmm.
And that gets you minus 56.3.
That's interesting. And so what is that in the form of R sine theta minus alpha?
So that is root 13 theta plus minus or
yeah, does it become a plus? But they wanted it in the form of minus.
Yeah. Would just be minus 56.3.
It might have to be. How do you get your second answer for sine?
You add 180.
You do 180 minus first answer.
Minus 180 minus 236.
So that's 236.3, and so is it minus? Is alpha gonna be 236.3 with a minus in front of it? I didn't get alpha for any of these, did I? What am I doing? Oh, I don't even have the answers. Okay, no. Okay, let's go to ones where I have the answers. This one, that's 2 and 3. That's a plus type. This is a minus type. Will this work? Okay. Let's see. So this is a cos type. Sorry, I thought these were already blank. And this is a minus type. I'm going to leave that. Okay. We'll do this. So match them up. Which one goes with which formula?
Okay. So for the one we just did, are we undecided whether it would be plus or minus?
Well, it has to be minus. So it has to be. So because of that, I believe that. Hang on. Let me just go back. Do I have the full question? I think they might have to state. See, I've cut these questions just to the bone. I think they might have to state what alpha is between, and it looks like they do because there's a comma after it. So I think if they had said alpha is between 0 and 360, in that case it would be the 236.3.
Right.
So
would it be?
So we would say root 13 sine theta minus 236.3 because it's minus alpha.
Okay, I think I understand what you're saying.
Yeah, so I just kind of cut it too much, and I thought I had the alphas. Here I must have been just focusing on the Pythagoras part. I just did this as a bit of revision. But this is, let's see. So this is a similar one. Not this one. Okay, let's do this one. So
okay. Express for where r is greater than 0 and alpha is between 180 and 0. Oh no, 90 and 0.
Yeah, so they are having to say that alpha is between something and something else. Like I thought so, and bigger than 0 as well. So my guess is that previous one they would have said alpha is between 0 and 360, and it would have been 236. Like alpha is 236.3, but in that form it would be theta minus 236.3.
Yeah.
Okay, let's try this one.
Okay. So 4 cos x, 3 sin x. So you do the Pythagoras part, which is 4 squared, the square root of 4 squared plus 3 squared, which is 5, as we saw earlier. And then we do the arctan of 3 over 4. And is it always arctan?
So it's always, well, if we look at this one, sorry, I'm using my red pen. If we look at this one, we have, it's, which formula does it match up with?
So would this be in terms of cos this time?
Yep.
So we'll be looking at the 4 cos x, so the cos a minus b.
So it'll work with that one, yeah. And so it will be the. So what is 4 equal to?
So 4 is b is cos b.
And the 3?
And 3 is equal to sine b.
And how would we get cos? Oh, sorry, how would we get tan?
You do 2 over 1.
Yes. So it'll be the second over the first again. It'll be arctan of the second over the first again.
But how do you get to that step, or how do you just decide that step?
Say it again, sorry.
So how do you know that 2 over 1 is arctan?
So this is basically simultaneous equations. So usually you might like add the 2, that doesn't work. You might subtract the top from the bottom, that doesn't work. You're now at a level where if you divide them, what you get is sine b over cos b is equal to 3 over 4.
Mm-hmm.
And that becomes tan b is 3 over 4, and then we can solve that.
Okay.
And it just so happens that because these are always, you can see there like sine cos, it's always going to end up as this technique working every single time. There is another technique where you can square both sides and do it that way, but this is just working. It's like you always use Pythagoras, always use arctan.
Okay. Would they ever ask for r tan x plus minus theta?
Yeah, they could. I think they would ask for tan 2a or tan 3a, something like that. Maybe not compound angle for tan, but I would check.
Should we see an example after this one?
Yeah, sure.
Maybe?
Yeah.
Okay. We'll finish this one, I guess.
Yeah.
So 5 cos x plus minus, and I need to solve arctan 3 over 4, which is 36.87.
36.8, so it says like 36.9 degrees. And so in terms of the way they wanted it, what is the final answer?
So this is minus 36.9. Would that be too small?
So that's too small, yeah.
This part is a part that I didn't really understand either. Trying to fit it into the range.
This, yeah, will this get in? How will we get this into the range? So alpha has to between 0 and pi over 2. So r was 5, so it was 5 sine x minus alpha. So we just got alpha as minus
36.9.
minus 36.9. Hang on. So this is, so I'm in radians. Arctan of 3 over 4. And I'm not getting a negative number?
Yeah, no, I got 36.9, but I put negative because of the bracket.
So it's 5 sine x minus 36.9.
Would that be okay?
Yep, that's the answer.
Okay.
Yeah, so we should have gotten a positive answer so that when we put it in, it looks negative.
And if it says between 0 and 90 or pi over 2, would you just add subtract from 180 or see the next time it hits the line and see whether it's in the 90 degree zone?
So essentially, we're just solving. It's a normal trig solving thing, and they'll say it's between 0 and 360 or between whatever. And if yours is outside the range, you just find the answers that are inside the range.
Okay.
Okay. So write this in the form of a compound angle.
So in the form tan A minus B.
Yeah.
Okay. I'll just write down the formula first. Well, since this one, it literally shows it in your face, really, because you can see that A is 76 and B is 45. So you just write tan 76 minus 45.
Yep. Tan 76 minus 45. And I suppose you could take it even further. What is 76 minus 45?
31.
So it's tan 31. And so sometimes you'd have to do it in reverse. But yeah, there you go. It's exactly tan 31. So tan is quite in your face. And then we can just take a quick look. There's a even further one. So any idea about this one?
Tan 2 theta plus tan 3 theta 1 minus tan 2 theta tan. Would you just replace A and B with 2 and 3 theta?
Yeah, and I think actually that one is the other tan one, the tan A plus B, which I might have to find. But yeah, you're right. You just replace it with A and replace it with B. Don't overthink it at all. I think this
with the tan 2 theta, you wouldn't use the compound formula for it, would you?
So I see what you're saying, but no, I don't believe you would. And I believe this is the plus type. And so what would this be if you put it into that form?
So 2 theta and 3 theta.
And so now fully simplify like we did before.
So 5 theta.
Yeah. So that's the tan variety of those ones.
Okay.
But you can see how it's, the much simpler than the.
Yeah. Could we go through the ones that I was given? Just look at them.
Yeah,
I
sure.
think it would be worth going through. So I'll just start with the top one. It's fairly similar to what we've been doing, yeah. But 2 sine theta plus 3 cos theta equals r sine theta plus alpha.
Plus alpha. What was the second part? Sorry, 3
cos theta, and it says show that r cos alpha is equal to 2 and r sine alpha is equal to 3.
Okay. R sine alpha is equal to 3. So this is a show that. So they're just trying to get you to prove it, basically.
Mm-hmm.
Okay. Any idea how to do it?
So we could try and find the r value first, using the Pythagoras, as we've been using before.
Yeah, you could, but you don't have to.
Okay.
This is for this one. What would you get if you were to expand this so it's not a compound bracket anymore?
Which one?
The right side.
So that would be r sine theta plus r sine alpha.
So it's not times, it's the sign of, so it's going to be using one of your 4 formulae.
Oh, yeah, it is.
So I can try to find.
I've got it here.
Okay.
So it would be the Sine theta cos alpha plus cos theta sine alpha.
Yeah, and so apply that to r and theta plus alpha.
So apply to the equation we have on the left, right?
Well, imagine there was no r. It was just sine theta plus alpha. What would you get?
Oh, okay. So you would have sine theta times 2, because the cos alpha would be equal to 2.
Don't get ahead of yourself. Just formula. Replace a with theta, b with alpha.
Okay.
So in the same way that the formula had a and b, and they wrote it the longer way, same thing.
So sine theta cos alpha plus cos theta sine alpha.
Yeah. And we removed the r, but now actually there is an r in front of it. And so it's going to be that whole thing multiplied by r. And so now multiply everything by r. What do you get?
So you get r sine theta cos alpha plus r cos theta sine alpha.
Yes. Alpha. I'm going to, you see this first one? I'm going to just swap them around and write it as r cos alpha sine theta.
Where's that?
Now just by comparison, 2 sine theta. And so what does that show you?
2 sine theta.
Yeah, remember, so this original question up here was 2 sine theta.
Oh, yeah. 2 sine theta plus cos theta times 3.
Yeah, so that's let's just write it as, we'll keep it as 3 cos theta, and we'll swap the other one. So r sine alpha cos theta. So I just put the cos theta, and so just by comparison, what do you notice there?
But we see that r cos alpha is 2, and r sine alpha is 3.
Yep. And that's
I see.
And that's what we did in the beginning.
Yeah.
I swapped them the other way, but yeah. So that thing that your teacher had you doing in school is just kind of to show you where it comes from.
Yeah.
And
then. Yeah.
And then you'd go from there.
And there's the part 2, which is hence find the values of r and a.
Okay, so that's
the value.
Yeah, so that's the bit I wanted to get to. So oh, sorry. Hence find the values of r and alpha, was it? Yeah. So that's what we've been doing. Is it worth doing? You want to do it?
Yeah, may as well just complete the question. So for the r, you do the Pythagoras, correct?
Yep.
So that's the root of 2 squared plus 3 squared. Which is root 13.
Okay.
And then values of r and alpha. To get alpha is the arctan of 3/2.
Yep.
Could you just remind me, it's always the cos which will go on top?
The sine goes on top.
Sine goes on top, and that's the sine from r sine alpha.
No, it is from the simultaneous equations down here.
Yeah. So
it's r sine alpha over r cos alpha gives us the tan, And so that's why it's the second over the first.
So arctan 3 over 2, which is 56.3. I think we've seen this one before. Yeah.
Okay, so they're running out of numbers. 2 and 3, you know.
Yeah. So then, it's root 13 sine theta plus 56.3.
56.3. Yeah, that's it. That's not quite the type I wanted to get to, but Any questions about that?
No, I just want to check if what that was the same as what we were doing before.
So that's what that one is like a little backwards because it's proving where it's coming from. But what we kind of got to was Pythagoras for the r and arctan second over first for the alpha.
Yeah.
So the where this is all coming from, or the reason why you would do that, is because what we saw in the beginning was we couldn't solve this. Let's say that's equal to 1. We can't solve it. But when it's written like this, if that was equal to 1, then we could solve it. And so that's where all this is coming from. So we could do solving it, or we could do different stuff. It's up to you.
How come you couldn't solve the first one if it was equal to 1 or not?
Using the method of dividing through by cos. So dividing through by cos worked when it was equal to 0, because 0 divided by cos x, nothing happens. Whereas if you divide a number by cos, then you get a mixture of tan and cos. So that's what we saw here. So 0 divided by cos x is 0. And so you just do tan x and you can easily solve it. These types of questions, dividing through by cos x, you still have a mixture of tan and cos. So we have to use the r sine x plus alpha or r cos x plus alpha, something like that, to solve it. I think that's what you should do next. Like a hence question where there's a solving it. Do you have one of those, or we can use one of mine?
I don't think I do, no.
Okay, so this is fine. I suppose what I could do, that one that we just did, what if it was y equals? Would you know what the maximum and minimum was for that one if it was a graph?
I think that happened in class, but I wasn't in for half the lesson.
Okay. Let's use the one we just did. I could do it, but anyway. So this one we did. So let's say this was the question.
Yeah.
That is equal to 2. Solve. How would you solve it? And there's a part B, and instead of it being hence whatever, the part B is hence solve it.
So the first part is to.
I'd better do it properly. So let's do this one.
Okay. So we're doing.
Sorry.
We'll do A and then B.
Yeah.
Okay. So 4 cos x, 3 sine x, r cos x minus A. So we do the comparison thing that we did before. We rewrite it in the form cos x minus A, or cos theta minus alpha.
So that's proving it. Let's just do the use our quick method. Get r, get alpha.
Okay. So with r, we do the root of 4 squared plus 3 squared. Which is 5. which I've done before, but I keep on forgetting.
Right.
And then it's arctan 4/3.
Yep. It's usually other way, isn't it? Second over first.
But since if it were written as 3 sine x plus 4 cos x and then find it in the form r cos x minus a, how would you determine which one would go above the other?
So isn't the formula cos alpha cos x plus sine alpha sine x?
Yes.
That's the cos x minus a. Alpha. So what matches with what?
So the cos x is the cos x and cos alpha is 4.
So 4 is cos alpha.
Oh yeah, and then that will go on the bottom.
Yeah.
Okay. I think I'll do that every time I do it just to check. Okay, so I'll write that down actually. That's 4 cos x 3 sine x. Okay. Alpha equals 3 cos alpha equals 4. Okay, so arctan 3/4 is 36.9. So then it's 5 cos x minus 36.9, as we saw earlier.
Okay, so yeah, it just keeps coming up with the same numbers. Okay, part B.
Part B, and so that equals 2. So 5 cos x minus 36.9 equals 2. Would you expand to compound angle formula?
No, you're just solving it.
So expand the brackets, just multiply out the brackets.
That's not possible. It's not multiplied, it's the cos of that.
Yeah, I need to remember that. Divide by x minus 36.9.
Again, not possible. It's the cos of that. So what could you do? You're aiming to get
divide
x.
Divide by the cos x for minus 36.9.
So then your x would be down on a denominator. So that's a bit worse.
Yeah. Would you bring over the 2? Make equal to 0?
What you're aiming for is it to look like that. X on the left, equal in the middle, number on the right. How can you make that happen?
How do you separate the x, well, the cos x?
Don't.
Um,
What could you do first? And in general, with brackets, outside in. So start from the very outside, work your way in. Divide by 5.
5.
So this is 5 times this. Divide both sides by 5.
Okay. So that just becomes cos x minus 36.9 equals 2 over 5.
Yep. What is next?
I'm really confused.
Or
lost.
So outside in, you can't mess with the bracket. So how do you usually get rid of cos?
You eliminate it one way or another.
How?
By dividing by cos.
That's not a real thing. What's the opposite of cos called?
Arc cos.
Yeah, that's what you're doing. So you don't divide by cos, you do arc cos to both sides.
Okay, I haven't encountered this before.
Yes, you have. You may not know it.
Okay.
So that gets rid of cos.
So is it just x minus 36.9 equals arc cos 2 over 5? Oh yeah, it does make a bit of sense.
And so what's arc cos 0.4?
Arc cos.
Or arc cos 2 over 5?
66.42. Oh, and then this, yeah. And now it falls into place.
And I'm gonna go on. What were you thinking? What's next?
Oh, and then you just add 36.9.
So that would get you one answer. How many answers did they want? Let's just use good practice.
Okay.
You know how? So we had to find this. X is between 0 and alpha. What is x minus 36 between? Sorry, 0 and pi. So to go from x to x minus 36, you'd have to subtract 36.
Yeah.
And so what is x minus 36 between?
Minus 36 and pi minus 36.
Yes. And so we would find all of the solutions at this point. So this is one solution, 66.42. How do you get second solution for cos?
Second solution for cos, you can add 180 because it's.
That's for tan.
Add 90.
Nope.
I'm trying to think of a graph. Subtract 180 minus whatever.
That's sine.
Well, 180 plus.
That's tan again.
Oh. 360 plus.
360 minus.
Plus minus, doesn't it do the same thing?
No. 360 minus 66.42.
Which is 203 or 93.58.
Let's see. Will there be a negative answer at all? What is that minus 360? Because it's just going to be the negatives. So we got 66 minus 66. It's going to be minus 66.42, is it?
Minus 66.5.
Okay, yeah. So it's just because we're constrained between 0 and pi, so we're only going to get one solution. So okay, okay. So
Did you not do 360 minus 293.58?
Then we go back to the first answer.
Oh yeah,
okay. So finish solving this one then. What do you get?
So then you have 66.42, and then you add 36 to it.
Yeah. What do you get?
Plus 36.9. Plus 103.32.
That's it. So you're in radians. This was in. You're in degrees. This was radians. What was the 2 decimal places? Sorry.
0.32.
32.
So would you then just multiply it by pi over 180 to get radians?
Yeah, you could do that.
Okay.
And it's roughly 1.8 according to this. Yeah, and so that's the kind of the point of these, that it's in a form that you can solve, and so you first put it into the form of r cos x minus alpha, and then you use that new form. They'll always say this part B, hence solve this equation, meaning use what you just did in part A to do part B.
Yeah.
And that's what this r cos stuff is about. So Pythagoras for the r, arctan second over first for the alpha, and if you want you can check, like what you were learning in school is where it comes from, and then once you have that, you use that form, like hence solve the thing, use that answer you just got and solve that.
Yeah.
And that's what it's all about. But trig ain't easy.
Fair to say.
Yeah, how was that for you, Gregoire?
It was good, thank you.
So anything in particular you want to do next time? We can do sequences next time if you like.
Yeah. Could